Hi everyone, welcome. I'm glad you could join me today. We made it to another past summit. It's a little bit different this year, but hey, 2020's been a little bit different. I'm really glad you're here. If you're watching this live during the virtual summit, thank you for taking the time and choosing this session. I think you've made a good choice, and I hope to provide you with a lot of good information. I'm Erin Dempster, and this is Navigating Row-Level Security. Before we go any further, I want to make you aware of session evaluations. Your feedback is important to us and to me. This is my first time presenting at the virtual summit, or past summit. I'm sure there are things that'll go well and some things that probably won't go so well. Hopefully those are minimized though. But I'd like you to let me know what went well, what didn't, so I can use that for future presentations. And if you submit your evaluation by Friday, November 20th at 5 p.m. Eastern Time, you're able to go into the drawing for prizes. And who doesn't like prizes? Before we really get started, a few words on behalf of PASS. So you already know a little bit about PASS. You're here at the virtual summit. But there's more that PASS offers. From local groups all around the United States and around the world, to virtual groups meeting online, there are often numerous opportunities to continue learning and do that social networking. Local groups also, a lot of them put on SQL Saturdays, which is a free one-day local training event. PASS also puts on PASS Marathon, which are back-to-back live webinars. And just all sorts of little goodies are available on the PASS website. After today's sessions, I would encourage you to go to pass.org and see what all PASS has to offer. A little bit about myself. Again, I'm Erin Dempster. I'm the Data Operations Team Lead at Trion Corporation. I'm currently living in Minneapolis, Minnesota. I've been a developer and a DBA really since about 2003 and became SQL certified in 2004. When I'm not working, I like to travel and do quite a bit of sightseeing. Obviously this year it hasn't gone that well, but I'm hoping in not too distant future I'll be able to do more of that again. Instead of flying, it'll be road trips, but hey, I'm good with that. Today, I'll give you an overview of row-level security. We'll walk through the steps to implement it. For basic implementation, we'll then look at enterprise scaling and how you can expand row-level security to work in your organization. I'll show a lot of this through demos, and then we'll have a wrap-up and have about 15 minutes for in-depth questions at the end. We'll see how this goes, so bear with me and try to hang on to those questions till the end. So, row-level security overview. What is it? Well, according to Microsoft, row-level security enables you to use user group membership or execution context to control access to rows in a database table. So, okay, largely we're talking about really filtering data. It's probably 80% of row-level security. And you see that through the use of the where clause or joins or however you want to do that. But row-level security will take it to the next level. But you might be thinking, I already have appropriate filtering. You know, all of my queries have where clauses where they need to be. Why would I want to look at row-level security? Well, you may have all the appropriate where clauses all the time, but you may not be the only person. With row-level security, The logic is applied to all queries for all users. You don't need to include the complex where clauses in every single query hitting your sensitive tables. And based on what your data is, row-level security can be flexible for you and be as flexible as your data allows. So, okay, sensitive data. What types of data do you have? What should you be thinking about? Well, how about HR information? Employees' salaries, their relatives, their home address, all of that personal information. Patient medical information, again, contact information. What are they being treated for? Their medications. Some people need access to that in the clinic, some don't. Maybe, in a patient's doctors and stat team needs access to that data, but do all the doctors and nurses need access to the information? Or just in any business, customer payment information. Should that be kind of out in the open, if you will, for everyone in the organization or those who have access to your SQL Server? Yeah, it's a little iffy. It depends on specifically what you have, but my guess is no. And then finally, also another example would be multi-tenant application data. With row-level security, you can safely have multiple organizations' data in a single database by applying row-level security to each of the tables in your database. In this instance, every table needs to be attended to and would be considered a sensitive table for multi-tenant data. Great. So what can I do with row-level security? What types of access control are there? Well, there's filtering, which are for select, update, and delete statements. And this is going to happen silently by SQL Server. Users may not realize that row-level security is enabled, that everything's going to work just fine as it is now. Blocking is the other type of access control, and it works with insert, update, and delete statements. In this case, it doesn't work silently, and it returns an error message to show or to explain that a blocking predicate is in place that won't let the user perform that action on the data. So it is robust. There's quite a bit you can do with this. So before we go any further, let's talk about where you can use row-level security or what you need for it. Your system considerations, it's on SQL Server 2016 and later. Across all editions, it's not an Enterprise Edition feature like so many things have been in the past. It's available on Azure SQL Database and managed instances. And you can find it in Azure Synapse Analytics. Please note that only the filtering is implemented. The blocking feature of row-level security is not available in Synapse Analytics. So that's a bit about what row-level security is and why you might want to use it. So now let's talk about implementing it. So what do you need? Well, first you need one or more tables that you consider sensitive, that you want to limit access for different users who are using it, using the database. To define the logic for limiting or filtering or blocking the data, we'll need a user-defined table-valued function, which I will call a predicate function. And then you need to have a security policy object that that binds the function to those tables. So, predicate function. Let's take a quick minute and review what the syntax of a function is. You'll have your function name and parameters, probably a parameter. And this is an inline table valued function, so it's going to return a table. And it's a select statement returning one value, one cell if you're looking at Management Studio. That's doing some relatively light, easy work. So as an example, I have a function called UDF sales predicate that this is used with the AdventureWorks database. My parameter is the business entity ID, which comes from the employee table. And I'm returning a result based on whether or not the employee is a descendant of the manager and the manager's login matches the the logged in username, and where our business entity are equal. So a couple of things I just want to point out really quick. As again, I said, the function needs to return a single result. So in this case, I have a 1. It doesn't need to be a 1. It can be any value, any string value, numeric value. 1 makes sense. We associate that with true, and so it works, but it isn't needed. Just keep in mind that that select value needs to be a single literal, really. So then once you have the predicate function, the other piece was a security policy. So there are some rules to know. Filtering and blocking can be enabled at the same time, and you can only have one policy bound to a table at a given time. So for sales order header, let's say from AdventureWorks, I can have one policy that's used for filtering, or I could have a policy that's used for blocking, or that same policy could be used for filtering and blocking at the same time, but I can't have more than the one policy or the one predicate function bound to the table. One thing to note is you can have multiple tables involved in the security policy itself, and I'll talk about that in a little bit as we see the syntax. So here we have our create security policy statement. We're going to give it a name, and then we're going to add either a block or filter predicate, giving the function name and the field name from a table we want to bind to. The field comes from the table we're binding to. You can additionally provide the state, whether when you create if it's on or off, and provide the schema binding. It can either be turned on or off. I would recommend schema binding be used and set to on, because that will help with permissions to underlying objects used by the predicate function. If it's turned off, which is valid, you will need to manage those permissions separately. It can be a little cumbersome and easy to miss those necessary permissions on the predicate function in any tables referencing it. So here's an example of implementing the security policy. We have I'm calling it security policy for sales. I'm adding a filter predicate on sales order header using the salesperson ID, and I'm adding a block predicate on the same table with the same column. I'm going to have it on by default, and I'll have schema binding on. So that's really the big pieces for row level security. And really what comes next is building that predicate function and really understanding what you need to have in the function to really get the data you need to be successful with the implementation. With that, I'll jump over to Management Studio and we'll get started. Here we are in Management Studio. We'll be using the AdventureWorks 2017 database. To get a proper row-level security plan going, we have two requirements. The first is members of the sales team can only see their data or their direct reports data. So in other words, if we have two salespeople who report to the same person or report to different managers even, they cannot see each other's data. They can only see their own, whereas a manager can see the data for the entire team. We can do that in this demo. The other requirement AdventureWorks has for us is for the rest of the company to be able to see all of the orders. This we'll get to in the second demo. So the plan for this first demo is to not implement row-level security right away, but start working our way up to it. Well, what would we have done without row-level security? How might we have handled this problem? And then we'll eventually get to a row-level security solution. So first, let's do a little data exploration. We'll take a look at the first 100 records of the sales order header table. So as you can see, we have some dates related to the order, some accounts, and we have other information such as, hey, the salesperson. That's pretty cool. That's going to help for our sales team. Let's take a look at this a little more. So we have salespeople listed, but then we have a bunch of null records. Okay. I wonder what's going on. Well, we'll also look at the online order flag. Oh, and as it changes from false to true, we lose our salespeople. Okay, so that makes sense. If you are ordering in person, you'll have a salesperson working with you. If you order online, you don't. So, okay, we can work with that. The other table we want to look at is employee. Besides the business entity ID, which will be our key to the sales order header, our fields of interest today are going to be the login ID and the organization node. The organization node uses a hierarchy ID data type, which will allow us to move up and down the management chain. Throughout this demo, we'll be looking at order counts and totals, and we'll be running it for different users. So here, on the right here, I have some helper data we'll be referencing throughout this. The first result set is a list of SQL users I've created ahead of time that are based on the logins within the employee table. And you can see who the job title of each person and where in the organization chart, in the organization they reside. I also have a summary of the orders broken down by whether it's an online order or in person. Again, we'll use this throughout the demo. So let's take a first stab at getting a solution going without row-level security. So we'll take our sales order header and join it to the employee with our key. We'll then join to the employee table again, where the employee is a descendant of the manager. So we have a manager and their employees, maybe another manager and their employees. And we'll filter this on the currently logged in user, or the user of the current execution scope. So we'll run this for Pam. And you can see that the manager's login is Pamela, and the employee's login. So with the is descendant of method, the employee can be a descendant of themselves. And you'll see there are 95 orders. Let's take a look at Pamela's manager, who is Stephen. Here you can see Stephen's orders, and as we scroll through, you'll notice the manager logins remain Stephen, but then we get the employees, Michael and Linda and Jillian, Garrett, and so on and so forth. So we can see our logic is working. It seems to be working the way we want. So instead of looking at details, we'll just look at counts and totals from here on out. So again, taking our same query and just getting a count, you can see we have 95 orders for Pamela. And for Stephen, we'll have a lot more. And Stephen is the North American sales manager, and his supervisor or manager is Brian, who is the VP of sales. So we'll run this and we get more orders. As we compare the two sides, it looks like we are only getting the in-person orders, which makes sense because we have an inner join on to employee, so we won't get our online orders. We can fix that, but we're on our way. You can see we've started the progression of filtering data based on the user. So we'll take this query and we'll break it out and put it into a subquery. So it's here we just are getting the sales order ID, and we're going to union that to a result set to return the online orders for the VP of sales for Brian. So we have a little logic here that if the organization level is 1 and it's an online order flag and Brian is logged in, we want to return those sales. So let's test this again. We'll start with Pamela, and you can see the top half of this query was in effect and the bottom was not, because the organization level for Pamela is 3, and we only care about online orders. So let's go back to Brian, and now we do get all of the orders back. We can see that the total orders on the left matches the total orders rolled up on the right. So let's refactor this just a little bit. I want to refine this, and bear with me. We're going to take a little leap of faith with me. So we're going to take the query that looks very similar to what we just ran, except instead of an inner join that we have here, we are going to do a cross apply. And with that, I'm also changing, I'm not going to return the sales order ID. I'm just going to return 1. And I'm going to do that on both halves. So we'll run this for Pamela, and we have our 95 orders. We'll run it for Brian, and we get all of the orders again as we want. So now we've really moved a lot closer to our row level security solution. So let's take this logic within the cross apply and create a function out of it. So we'll do that. Our parameter is going to be business entity ID. And here we have our union query again. And it's an inline table in our function. Let's create that. And now let's test the function with the sales order header. Again, we'll run this as Pamela. And what do you know? We have our 95 orders. And I bet if we run this as Brian, we'll get all 31,000. Always remember to run the revert when you're executing as a user. You can't switch between users. So yeah, there we go. Our orders match up. That's interesting. Why is that working? Well, let's go back up here. And it comes down to our where clauses. We've done all of our logic in the predicates of these queries. And so now we just have a scalar result. In the slide deck, we talked about that. We wanted to return a single scalar static value, a literal, which is what we're doing. And we can see that we're only we're getting one value back if the rules pass, if the user has access. So for 280, this is Pamela's business entity ID. We get back a 1. If we look at Stephen and have Pamela try to query the function for Stephen, we don't get anything back. We don't get a null, we don't get false, we get nothing. So let's change this to Stephen. And now, of course, he can see his own. And if Stephen wanted to run this function looking at Pamela's data, he can see that as well. So having that one cell is really, and using the cross apply is what is doing our filtering. So again, we'll run this as Brian, and because we've defined our function to return all data for him, we're always going to get a 1 regardless of the business entity ID. And it can be null. What we pass in can be a null value. And the second half of our union kicks in and still returns the 1 because we are logged in as Brian. Now, if I run this as myself, I'm going to get nothing returned, no results in any situations, because we didn't create a case for me. So now that we have the function and it's our predicate, let's go ahead and bind that to the sales order header table through the security policy. So here we're creating security policy and we're adding a filter predicate using our function on the salesperson ID. So again, we'll run this query as Pamela. Notice it's just select from sales order header. There's no where clause. And we once again have our 95 orders. Run it as Brian, and guess what? We have our 31,000 orders. So we've done it. We have a row level security filter predicate on our sales order header table. And again, I'm just going to get 100 records from sales order header and sales order detail using my own access. And as I showed before, I don't see any data in sales order header because nothing's been defined for me. The security policy is only in effect on the sales order header, so when we query sales order detail, I can see all the data just fine. In the next demo, we'll fix the problem so that I can see the data, or really your DBA, as well as giving the rest of the company access. But before we finish this demo, I do want to take a quick look at blocking predicates with row level security. To this point, everything's been a filter. So first we'll drop the security policy, and then we will recreate it with our filter predicate as well as the blocked predicate. So then let's insert a record into sales order header. Something's gone wrong in the application. They've come to me and said, please fix this, Erin. We need your help. Well, I've gone in and tried to run the insert, and I get this error message. The attempted operation failed because the target object sales order header has a blocked predicate that conflicts with this operation. So again, we use the same function, and it behaves very similarly, that where I couldn't see data because it was being filtered before with the select, it's now just flat being blocked on an insert. So this is Pamela who needs the data. So we'll run this. And I'm sorry, I have the wrong salesperson ID. This isn't Pamela, this is Stephen. So you can see it also blocked for her. So let's run this as Stephen. And now our record was added. So we use the same predicate function to do filtering and blocking on the sales order header table. Returning to the slides, let's take a look at what we've implemented at Treon with row level security. So a little bit about Treon Corporation. We're an insurance management company, and we have 2 insurance carriers, and both carriers have multiple insurance programs. Currently we have over 50 insurance programs and growing. And with row level security, we needed to limit data access. Treon staff can see all the data, but insurance companies can only see data for their programs, and for each program they can only see their data. So you can see that hierarchy, similar to what we had in the demo with AdventureWorks. We're just looking at this as a company level instead of each employee. Other requirements that drove us towards role-level security included all queries needed to be filtered. Whether it's a developer who's doing some troubleshooting in production or an accountant using Excel to query the data warehouse, all the queries needed to be filtered. And we only wanted one copy of the tables within our system. So we're using the data warehouse. We didn't want to have a data mart for each program or a data mart for each insurance carrier or a separate data mart for Creon. We just have one data warehouse. So that's an enterprise solution and has some requirements for scaling. So to do that, we use some existing functionality available to us in SQL Server, including database roles and outside of SQL with Active Directory groups. We were smart and used mapping tables. Oh, we were not that smart, but we used a mapping table, and we used the isMember function to determine whether the user is a member of a role or a group. So let's take a look at this within the context of our AdventureWorks demo. Back to Management Studio we go for the second demo. In this demo, again, we're going to use concepts we just saw in the slide deck to scale out our role-level security solution for the enterprise. Let's look at a new user, Mary. Mary is a marketing specialist, and when we run our query, we don't get any orders back because, again, she's outside the sales team, and our predicate function only dealt with the sales team. So let's start making some changes. First, we're going to drop the security policy. Be careful when you do this. Find time to totally take applications offline that use your database, because right now, while changes are being made, data is fully accessible. So anybody can see that sensitive data that we're working so hard to protect. First, let's create a role. Let's call it All Access. And let's add Mary as a member of the role. So now with our function, we have the same two queries union together that we've had, and we'll add a new one. We're going to use the isMember function this time to see if Mary is a member of the All Access role. So we'll make the change, and we'll create the predicate or the security policy. And now you can see that all of the data is coming back, which is what we want. So that's a really simple way to bring everybody else in to see the data. But maybe we want to add a little more complexity to where certain users can see certain territories within the database. So to do that, we'll go ahead and remove Mary from the All Access role. And again, we'll drop our security policy because we're going to make some changes. So to define access based on territories, let's look at our sales territory table. We can see a number of US regions and with the territories, and we have a few countries in Europe. So we'll go ahead and create two roles, US sales and EU sales. I've already created them previously. And I'm going to add Mary to US sales and Amy to the European sales. So then in our function to use that, we can come in and start listing out the territories and which groups, which roles they belong to. It'll work just fine. Let's do that. So running the query, we've added territory name to our query to break things out a little bit. And you can see now we're getting the US territories. If we change our user to Amy, sorry, I didn't revert the context. If I run this as Amy, they only see France, Germany, and the UK because they're added to the EU sales. I could continue this, updating the function, adding in all the regions and mapping them to roles. That's not a problem, but it's going to get a little cumbersome after a while and it requires more maintenance. So instead, let's streamline this and create a mapping table that maps a territory ID to a role name. I've already done this. I've run through this demo a few times. And you'll see that I've added records for the US sales and the European sales. So I'll skip these inserts. And once again, we'll drop the security policy and we'll recreate it. This time we bring it, shrinking it up a little bit. We have our sales order header is joining to territory roles, where a role name is being evaluated by isMember, and we're looking at it at a sales order level. So once again, we'll run this for Mary, and we still get the same results. And for Amy, we get the same 3 returns. That's excellent. To do this, we used roles to go with our SQL users. You can also use Active Directory groups and either look for group membership with the isMember function, or you can assign groups to roles and check on the role membership. From a performance standpoint, I would recommend that you add the Active Directory groups to a SQL database role and evaluate the isMember function against the database role. When in some situations you can see some performance issues with SQL Server going out to Active Directory to your domain controller to get access information. So querying the database role is internal and much faster. So now, at this point, we had taken out the ability of our sales team. So let's add that back in. Once again, we'll drop the security policy. And we'll alter our function. We have our territory lookup, and we're back to our sales. For the sales team. When I run this for Mary, we get the 5 regions we had earlier. Let's go back and run this as Pamela. And notice that we are back to our 95 orders that we've always had. And we now know that the territory is the Northwest US. So by using the territory roles mapping table and the isMember function, we've been able to reduce the complexity of our predicate function and allow a lot more functionality, which is really key with row level security. You want to do as little as possible, but still getting in everything you need. So that's a wrap for this demo, and we'll return to the slides to wrap up the session. At this point, we've progressed through the implementation of row level security for AdventureWorks. And I just want to hit upon a few things that came up in the demos that are really key. There's some wisdom I came across a while back from Steve Jones. He said the return value is typically shown as a 1 with some column name, which is what we did in the demos today. But it's important to remember that as long as something is returned, the user has access to the row data. The result does not need to return a 1. So in all of my examples with the predicate function, it was a select 1 as the result. I could have said select pass or select true as the result with the same from and where clauses. It's really, and I showed it a little bit in the first demo, where when a user didn't have access to the business entity ID, such as Pamela trying to query Stephen, we didn't get any results. It was blank. There was not a 0. We didn't get a 1. There was just nothing. And that is the key to row level security. So going back to our predicate function, here's a template, or here's the function I created for another demo. And within the return, we have our isMember. We're doing select isMember, the role name as the result, where the program ID is being evaluated. It's good that we're evaluating the program ID, but bad that we have isMember in the select clause, because it returns one of 3 values, true, false, or null. And in all of those cases, they would grant the user access to the record. So again, using the examples from today, this is from a previous demo, but it looks similar to what we did today. We were doing a select 1 for a result value, and we're doing all of the work within the where clause. Again, that is the key to row level security and having a successful predicate function, is to just have all the logic in the where clause and a single value in the select clause. It makes a lot of sense, but as you're working with your data and you think you have complex situations, just remember to be simple. Keep it simple and keep that select 1 as a result, and it'll help immensely. So let's wrap up the session. And remember that with row level security, a single table like our sales order header supports 1 security policy. You can have blocking and filtering both enabled at the same time, but you can only have the 1 security policy. The predicate function should be relatively simple, and it should be quick. This is going to be run all the time against that table for every user. Look at using roles and groups for enterprise databases, or really any database where you're implementing row level security. As you saw in the second demo, the use of the roles and groups along with the mapping table can really help simplify the logic and provide a more robust solution. And again, I can't stress this enough. Remember that the predicate function is always applied to every user, regardless of who they are, when the security policy is enabled. And before I forget, please fill out session evaluation. I've covered a lot of information today. I hope it's been useful. I hope it's made sense. If it didn't make sense, please let me know where I went wrong, and so I can improve for the next time. And again, if you submit the evaluation before November 20th at 5 p.m. Eastern Time, your name will go in drawing for prizes. Thank you very much for your time. I'm glad you stayed and took this opportunity to learn a little bit about row-level security. Thank you.